Homework questions number 1 to 4 were just about stating whether it's a parameter or statistic. So whether the number describes the population or the sample, and then use appropriate notation to describe each number. The two numbers that you were looking for in number 1 were the 2.5003, 2.5009. Okay, so try to determine whether it was a number describing a sample that they took or whether it was describing the whole population. Okay, well, you see a carload, a lot of ball bearings, has mean diameter 2.5003. Okay, and then later, by chance, he chooses 100 bearings. Okay, that would make this first one be a parameter, 2.5003. And X bar out of the sample of 100 is 2.5009. The Bureau of Labor Statistics last month interviewed 60,000 members of the U.S. labor force, of whom 7.2%. Well, are those 60,000 the entire U.S. labor force? No. So it would be p hat equals 7.2%, or you could have said 0.072, of course. A telemarketing firm in Los Angeles uses a device that dials residential telephone numbers in that city at random. Of the first 100 numbers dialed, 48% are unlisted. That's the sample, p hat equals 0.48. Okay, this is not surprising because 52% of all Los Angeles residential numbers, so that's all of them, that would make it p 0.52. Okay, a researcher carries out a randomized comparative experiment with young rats to investigate the effects of toxic compound in food. She feeds the control group a normal diet. The experimental group receives a diet with 2,500 parts per million of the toxic material. Okay, and then for each group we have a mean weight gain of that and of also that. Okay, well, are either of these about all rats ever, or in the United States, or in their city? Okay, both of these are samples. They're comparing two sample groups against each other. That first sample group, so you could call it X bar 1, or you could call it X bar control, X bar experimental, and so on. That one would be 335. Okay, X bar 2 would be 289. Do you drink the cereal milk? A USA Today poll asked a random sample of 1,012 Americans what they do with the milk in the bowl after they've eaten the cereal. Okay, of those respondents, 67% say they drink it. Suppose that 70% of U.S. adults actually drink the cereal milk. Okay, find the mean and standard deviation of the proportion p hat of the sample that say they drink the cereal milk. Okay, well, the mean of p hat is equal to the true population proportion. So a lot of times you're given information that realistically, if we already knew this, we wouldn't be doing this experiment or this sampling. Well, the average of all the proportions is the population proportion. That means the average of all the sample proportions is 0.7, because we have that number in the problem. 70% of U.S. adults, of all U.S. adults. Okay, standard deviation. P, 1 minus P over N. Okay, so that would be the square root of 0.7, 1 minus 0.7, over how big was the sample size? 1,012. Okay, so as you work that out, you should find that that is going to be 0.0144. Okay, that's A. Explain why you can use the formula for standard deviation of p hat in this setting. And the book calls it rule of thumb number 1. Okay, this is where we need more than 10 successes and also more than 10 failures. Actually, sorry, that one's for the second one. Okay, this one is where we need N to be less than 10% of all U.S. adults. Okay, so is 1,012 less than 10% of all U.S. adults? Absolutely. Okay, again, what you can do is multiply it by 10 and see if that's smaller than the entire population. Okay, so 10,120 is less than all U.S. adults, or 1,012 is less than 10% of all U.S. adults. And it is good, especially on your test, to write it out that full way. Okay, in order to use the normal approximation, we need to expect more than 10 successes and also more than 10 failures. Okay, well, the 10 successes, 10 failures, both of them are going to be easily obtained. Okay, so it would be 1,012 times 0.7, which is 708.4. Okay, and it's also 1,012 times 1 minus 0.7, or times 0.3. Okay, and so that one is 303.6. Both of those bigger than 10, so we're good there. Okay, so letter D is going to help you with what you're doing today in class. So find the probability of obtaining a sample of 1,012 adults in which 67% or fewer say they drink the cereal milk. Okay, so here's your normal distribution, 0.7 in the middle. Okay, 0.67 was our sample proportion, so your mean goes in the middle. What they found for the sample goes elsewhere on the normal distribution. Shade it in the direction they want. Okay, and then your z-score formula. Z equals p hat minus p. So it's the statistic, that's the number describing the sample, minus the parameter for the whole population, okay? Divided by the standard deviation. For sample proportions, it's p1 minus p over n. Okay, square root of all that. So, in this problem then, substitute in the values that you know. You know 0.67, okay, that's the one that's not in the middle. If you need help figuring out what goes where, that's the one that's not in the middle. Minus 0.70, and then the bottom part is a mess. Just be really careful when you plug it in, and you should be fine. 0.7, 1 minus 0.7 over 1,012. That entire thing needs to be under the square root. The top part, if you're typing it all in at once, should be in parentheses. Okay, that gives you a z-score of negative 0.25, or negative 0.25. So go to table A, look up negative 0.2 in the left column, 0.05 on the top, find the intersection, okay, and we find from table A the probability of getting this would be 0.0186. Okay, let's look back at their question then. Do you have any doubts about the result of this poll? Well, we can at least say we only had a 1.86% chance of getting this result. So do you have any doubts? Yeah, it's pretty rare. I mean, it's rare. So, yes, because it was a really rare event. There was only a 1.86% chance of this result. Okay, what sample size would be required to reduce the standard deviation of the sample to 1/2 the value you found in A? Okay, well, look over on the right here, what I just highlighted in blue. In order to cut a fraction in half, you have to multiply the denominator by 2. Okay, but in order to cut a standard deviation in half, since it's underneath the square root, you have to multiply it by 2 squared. Okay, so what sample size would be required? Well, we have to multiply our original sample size of 1,012 times 2 squared, or 4. So a sample size of 4,048 would cut our standard deviation in half. Like we talked about before, that can be really costly. Okay, if the pollsters had surveyed 1,012 teenagers instead of adults, do you think sample proportion would have been greater than, equal to, or less than 0.67? This one's up to you. The question really is, do you think teenagers drink the milk more than adults? Okay, so whichever answer you give, just make sure you support it. If you say higher, then you should say it's because teenagers drink it more. You say lower, then you should say it's because teenagers don't like milk as much. If you say it's the same, then you could say it's because there's no real difference between adults and teenagers in how much they drink cereal milk. Okay, number 9.25. Gallup poll once asked a random sample of 1540 adults, do you happen to jog? Suppose that in fact 15% of all adults jog. Mean and standard deviation. Remember again, mean is the mu of p hat is the mean they're looking for, and that's equal to the population proportion, which is 0.15. That one's good. Okay, also, standard deviation, sigma p hat. It's the square root of p 1 minus p over n. So again, this one is 0.15, 1 minus 0.15 over 1540. Square root of all of that. Okay, so when you type that into your calculator, again, it's best if you can put it all in at once. Just be really careful with the division, group stuff in parentheses, and so on. That gives me a standard deviation of 0.0091. Okay, why I can use the formula for the standard deviation of p hat. Okay, this one, asking you to check 1540 less than 10% of all. Where did they get their sample from? So what's the population that we're talking about? 1540 adults. The Gallup poll asked adults in the United States, so of all U.S. adults. Okay, that is true. There are more than 15,400 U.S. adults. Alternately, multiply it by 10 and check, is the whole population bigger than that? Can we use the normal approximation? We can use the normal approximation because we have more than 10 successes and failures expected. Okay, can you just say that? No. Okay, you have to work out some of the calculations. So the calculations are that NP is greater than or equal to 10, that's more than 10 successes, and N1 minus P is greater than or equal to 10. That's your 10 failures. So we have 1540 times the true population proportion of all adults who jog, 0.15. Is that greater than or equal to 10? Also, 1540, 1 minus 0.15. Is that greater than or equal to 10? Okay, so the first one being 231, the second one, 1309. Both easily greater than 10. We're allowed to use normal approximations. Okay, so what's the probability that between 13% and 17%? Those are your two p hat values. So we're going to be looking at a calculation like yesterday that requires you to find between two values. Now, fortunately, since our mean was 0.15 and both of these are equidistant from that middle, we're going to be fine. Because once you find that upper z-score, you're going to know the lower z-score as well. Okay? So, your z-score formula, and we're allowed to do this because it was a simple random sample, because n was less than 10%, and because np was greater than or equal to 10. This is going to be p hat minus p over p 1 minus p over n. Again, being careful with how you plug this in. Okay, that's going to give you, for this first one, 0.17 minus 0.15 over 0.15. So be careful, in that bottom one, you're plugging in the population value, not the p hat value. And our sample size was 1540. Okay, so double check what you're going to get there. You'll find the z-score, though, is around 2.198 or 2.20. That means the lower one, if you would do 0.13 minus 0.15 over 0.15, 1 minus 0.15 over 1540. That's going to give you just negative 2.20. Okay, so look up that top one in table A, double check what you get, look up the bottom one, table A, so negative 2.20, look what you got, and subtract the two z-score values, the two probabilities, and you're going to get 0.9722 is in between the two. Great. Lastly, what sample size would be required to reduce the standard deviation of the sample proportion to 1/3 the value? Remember, this is the bottom of a fraction inside a square root. So it's whatever number we want to reduce it by squared. Normally, to cut it in third, you would divide by 3. Now you're going to need to multiply it by 3 squared. So it would be 9 times our original sample size of 1540. Okay, and we would need a huge sample, much larger than it was. Okay, about 13,860. All right, so now you should be able to do that sample proportions homework. Number 1 to 7, and just leave it before you leave. No homework this weekend. Over spring break. Have a nice break.